So hopefully you've had a chance to take a look at this system of equations, and the system has two equations in it, so we're supposed to find the solution, and the solution is always involving an x and a y in the problems that we've been doing, so this one's no different. The main thing is that we need to solve for y. So the first thing we're going to do is we're going to take this first equation and we're going to rewrite it using the laws or the properties of logarithms. And the property of logarithms in this particular case, we take this 3. Anytime you have a number out in front of a log, you get to move that number to the exponent position. So that's what this is going to look like. We're going to take the ln of x, and we're going to set that equal to the ln of y to the third. So we just use the property that says you can take the coefficient and move it to the exponent position. And now the next property of logarithms that we're going to use excuse me, is if you have a log on both sides of the equal sign, which we do, and the log has the same base, which it does, then the arguments, whatever you're taking the log of, those have to be equal. So we just drop the logs. We're not dividing by logs, we're just dropping the logs, because for the equation to be true, the arguments have to be equal. And so therefore we get y equals, well, let's go ahead and take the cube root of both sides. Cube root of both sides, solving for y, we get y is equal to the cube root of x. And we always like to see it like this, so y equals cube root of x. That's our first equation involving y. Okay, I don't like that color. There you go. So then we do the same thing for the second equation, and what color would be good right there? White. Okay. For the second equation we get 3 to the x. We have 3 to the x equals 27 to the y, but 27 can be rewritten as 3 cubed. Okay, and so when we do that, we use the property of exponents that says that power to a power, these two guys right here get multiplied together. 3 to the 3y. And so we can write it as 3 to the 3y. Now, just like in the other problem, when in the other one we had logs, this one we have the bases are the same. So anytime on both sides of the equal sign you have the same base, that means that the exponents have to be the same. And so we just rewrite the equation dropping the 3's because the exponents have to be the same, and that way we can solve for y, dividing both sides by 3. We get y equals x over 3. So x over 3 is one value for y, and what did I put that in red on the other side? Okay, so we have our two equations, and now we can, if you want to, you can just rewrite this as y equals cube root of x, y equals cube root of x, and then y equals, I can't remember what I had there, so let's see, y equals x over 3. Okay, y equals x over 3. So the first one will be your y1, second one will be your y2, and when you program those two functions into your calculator, so by plugging these two functions into the calculator and then showing the graphs, hitting second, calculate, intersect, and finding all of the points of intersection, we see that there are 3. Okay, which at first glance you might think, all right, I'm done, but just like in any equation, you need to make sure that the solutions that you find satisfy both of the equations up above. And as we can see here, let me use this nice pink line. This pink line is we're going to draw it right through that solution there because both x and y are negative. And if you look up here above, we've got ln of x and we've got ln of y. And we're not allowed to take the log of a negative number, nor are we allowed to take the log of, let me get a thicker pink line, nor are we allowed to take the log of 0. So both of these first two solutions are bad solutions. They don't work. They don't fit you're not allowed to plug those into both equations up above. And so therefore we only have one solution that's actually the solution to the problem, and this is it right here. Okay, that's the only one that will work in both equations. That's it.